So hey guys, my name is Parik and today's video we are covering up what? Sigmoid activation function, yes. And also the derivation of sigmoid function. Okay, you have heard about that derivation of sigmoid function in CNN model. Its ranges between 0 to 0.25 or 0.25. So why it's like that? Okay, we will discuss in the second, but first we observe what is a sigmoid function and why it is used. Okay. So we know that the sigmoid function is represented as what 1 upon 1 plus e raised to minus x, or whatever the as x is represented as z. Okay, z is nothing but the weight will be multiplied as the input and y is going to add. Okay, nothing else. Okay, so as you can see from the graph, okay, so this sigmoid function is somewhat like this. Okay, it is somewhere like increasing and somewhere like decreasing. Okay, so this is a nothing but it's a very good, I think, towards data science blog. I will put this link and you will understand better from this, but it covers all the activation function, but I will be covering the derivation part also. Okay, don't worry that. Here they have mentioned that function is monotonic but function derivative is not. Okay, so it's saying that the function can be increased or decreasing. Okay, as you can see from here, but the derivation is does not. Okay, somewhat like that. So why it's happening in if you have the hello world program of CNN models, means nothing but a cat dog classifier. Yes, so what we do, we usually go for ReLU activation function in the hidden layers. Okay, but we and in the output layer we usually go for sigmoid function. So why we are doing this? Because you know we have learned from the YouTube or many of the online courses that we are usually using the ReLU function because it's a non-linear. So we have to achieve the non-linearity. Okay, that's the other thing. But the sigmoid function is not helping us to updating the weights. Okay, so if the weights are not updating, I cannot achieve the global minima. Okay, so that can be understandable thing and mentioned thing that we can understand. So you can use the sigmoid function in the hidden layers, but if you see the output, I think the output that will be not much, you know, that in the that peak. Okay, so yeah, it's one thing. And also the sigmoid function, in the sigmoid function in the output layer is present as a probability distribution function, because it's gives us the probability of that particular class if it is 0 or 1. Okay, in the cat dog classifier, or more than that, means I can say classes are there. Okay, so let's just discuss about the derivation of the sigmoid function. Okay, so our question is why it is ranging between 0 to 0.5. Okay, what is that? Okay, so we have to understand the first of all the derivation part. Okay, so what I have to do, we have to go for the we have to first go for the function of sigmoid. Okay, 1 upon 1 plus e raised to minus x. Okay, so if we go for derivation, okay, so if you don't understand the derivation of division, please I suggest you to go to the online and just see the formula and apply it over here. Okay, so first we have to do the derivation of what? Numerator. Okay, so however here I have done the numerator of the derivation because the one derivation is 0, and you have to just put the denominator as it is, and you have to do for e raised to 1 plus e raised to minus x. 1 is becomes 0, e raised to minus x become minus e raised to minus x. Okay, and the sign is minus. This is the formula. Okay guys, nothing else. And I have put 1 over here, and the denominator comes 1 plus e raised to minus x whole square. Okay, so this is nothing but the first derivation we have described for the sigmoid function. Okay, dy by dx. So okay, so our assumption from the graph. Okay, let me see. So somewhere like graph. Okay, assumption from the graph, we can understand the graph somewhat like this in the sigmoid function. Okay, if you see from x equals to 0, graph is peaking. Okay, it started increasing. Okay, but if you see the so what happens when the x equals to 0? If we put x equals to 0, so what it going to be? 1 by 0, because what? The dy by dx. Okay, so here, so 1 upon 0 becomes infinity. So y will be ranging plus or minus infinity. So we have not assume, but we get the insight from the graph. Okay, but let's go for mathematics part so we can understand it better way. Okay, so Okay, so what we have to do, we have to go for another derivation of the means we have to do the second derivation of that function. Okay, so what we have get over here, e raised to minus x upon this, we have to do the second derivation of that. Okay, so it becomes a little bit handy or a little bit confusing, but don't worry. Okay, whatever we do in the first derivation, we have to just somewhat like do over here. If you are the maths is somewhat like, it's not that good, but don't that like that, just understand from here. Okay, you will get to know about why it's ranging between 0 to 2.5 or 0.25. Okay, so I have done the derivation part. Okay, I have put the denominator as it is, and then you have to done for e raised to minus x. Okay, you can see the minus I have put over here. The minus will be the as from the formula. Then I have to do for this over here. This is considered as x square. Okay, you can consider as a x square, and then you can do it. Okay, so it will be very easy to use, easy to understand. Okay, and nothing else. Okay, so I have common it out 1 plus e raised to minus x, because here is the square. Okay, so one is remaining, so I forgot to put it over here, so you can just multiply it with e raised to minus x. Okay, and whatever parts come here, I have just because if you see from here, we have to common in it out 1 plus e raised to minus x. So what it becomes, e raised to minus x, e raised to minus x, so it becomes e raised to minus 2x, and 2 is over here, and minus minus plus. Okay, so we have cut out the from 4 degree to 3 degree. Okay, just somewhat like over here. So if I show you the next image, okay, I have, yes, okay, I have to rotate it, sorry for that. Rotate resize, maybe resize, sorry, okay, sorry for that. Okay, so just nothing, just I'm addition, and the subtraction is over here. Okay, because if you see e raised to the minus x minus e raised to minus 2x is so minus e raised to minus 2x plus 2 e raised to minus 2x become e raised to minus 2x, and this is as it is, we have to put it. Okay, and I have common it out. Okay, e raised to minus 2x into 1 minus e raised to x, that we have get. Okay, so now our assumption is what, that x is equals to 0, the graph is going to be big. Okay, so let's take the e raised to minus 2x equals to 0, and we get that will be a no such solution of that. Okay, so let's go for the another 1 minus e raised to x. Okay, so 1 minus e raised to x equals to 0, e raised to x equals becomes 1. If you are not from the math background, you don't know about this. But if the e is transforming to that side, okay, means right hand side, it will become log. Okay, and log of 1 becomes 0, and so we get that. Okay, let's take the x as 0. Okay, from graph we have understand that x is 0. From mathematical equation that we have derived, the x is 0. Now the both side are equals, so let's put our x into the first derivation. Okay, so our first derivation was, if you don't remember, I have just put it over here, nothing else. Okay, so I will be going to put x equals to 0. Okay, so if you say e raised to 0, 1 plus e raised to minus 0, it's nothing like that. E raised to becomes e raised to 0, e raised to 0, e raised to 0, what, 1 raised to 0 becomes 1, 2 raised to 0 becomes 1. So e raised to 0 always it's going to become what, 1. So 1 upon 1 plus 1, it becomes 2, and 2 square equals to 4, and 1 by 4 equals to 0.25. So we get our answer that derivation of Sigmoid function will be ranging to 0.0 to 0.25. Okay, so that's why we generally go for ReLU activation function, and we avoid sigmoid, but it's somewhere in the CNN model we go for sigmoid, but generalized form is that we use ReLU. Okay, yes, and this is the main idea behind this. Okay, that your instructor or your guide is saying in a course is like that the derivation will be ranging from that, but we need some proof of work. But yes, so we get from here. Okay guys, if you like this video, please try to make a subscribe, and please try to make it share, so I will grow more, and you will get the knowledge from these things, okay. And I will come up with the new CNN model, that other model that we have achieved 75%. In next video we are going to achieve 90% accuracy with the flash scan, okay. Don't worry guys, we are going to see lots of things over here, okay. If you have query, if you have in a back propagation theory problem, just put the comment, I will going to make on that, okay. Please guys, okay. If you have any query regarding in a CNN model, in a deep learning model, please try to make in a comment, okay. So we are going to, I'm going to create this video particular, okay. So let's see in the next video.